So much. All right. Keep things moving. We've got a few more presentations for the day. I hope everyone is staying limber and good to go. Next up, we are going to talk about end-to-end type safety, a tale of three domains, with Tasin Ishmam from Prisma, developer advocate. Tasin, welcome. How's it going?
Hi, Brian. Thank you. I'm good. How are you?
I'm doing well. I'm looking forward to hearing three tales today. So I'm going to let you take the stage and take it away.
Oh no, I only prepared once.
Oh,
All right, let's see if it's convincing enough. Hey everyone, welcome to my talk. It's called End-to-End Type Safety, a tale of three domains. So, as Brian mentioned, I'm Tasin, a developer advocate at Prisma. So, at Prisma, we focus on developer tools that make developers more productive. We will talk a bit more about Prisma during this talk. We mainly focus on database tools. So, today we are going to discuss end-to-end type safety, and we'll explore what that is, why it might be useful for you, and how you can implement end-to-end type safety in your application. So in this talk, we will be using the example of a full stack TypeScript application. However, end-to-end type safety is relevant even if you're not using this stack or are using totally different languages on the back end and on the front end. So first, let's start with the what. We will first define what type safety is and then move on to end-to-end type safety, just so the distinction between the two is a bit more clear. So type safety means that the compiler will validate your types at compile time and possibly at runtime and throw an error if you try to use the wrong types for a variable. As you can see, this is not my definition. Type safety is built into some strongly typed languages like Java and Golang. Weakly typed languages like JavaScript are not type safe. Nowadays, though, we have TypeScript that adds type safety to JavaScript. This is what the syntax looks like for TypeScript. It's pretty much vanilla JavaScript with some syntactic sugar added for defining types. This sort of type features is quite useful. And the TypeScript compiler will complain when there's any kind of type mismatch or type-related error. And this is, while immediately useful, manually adding types in your application can leave those types inconsistent if you are not doing it properly. And we'll talk a bit more about it. We'll give you an example. So here you can see a GraphQL schema with a single query where you can fetch an article by its ID. And here is the resolver that implements the article query in that GraphQL server. And it's written using TypeScript. And this implementation is reasonably type safe. But there is a subtle bug in this implementation. So what is that bug? I'll just give you like 10 seconds to quickly read through it. So here you can see that the GraphQL schema, the ID field is actually optional or nullable, but inside your resolver implementation, it's not nullable. It has to be a number. And this is an obvious mismatch, but TypeScript has no way of knowing this because it has no knowledge of your GraphQL schema. So TypeScript will happily compile this code, and you will probably get a nasty surprise when you're running this app at some point. So there's clearly more to type safety than just having types for everything. You also need to make sure that the types are correct. This is obvious, that they actually represent your business logic accurately. And two, that the types are consistent across different domains in your application. And when I say domains, I'm talking about the different layers that make up your app, like the front end, the back end, etc. So this consistency is what our previous example was failing to achieve. Even though the code was strongly typed, the types were not consistent between our GraphQL schema and our API server. And just to recap, we defined what is type safety, and we also explored one of the potential issues of this mismatch that just adding types will not solve. Now let's define end-to-end type safety. So end-to-end type safety means that your entire application, all the way from the database to the client, is strongly typed. And these types are consistent across the different domains of your application. So in order to achieve this consistency, you need to have types for the boundaries between different domains or layers of your application. A typical web app has to deal with quite a few of these boundaries. So let's talk about that a little. A web application will have a client. This is what the user sees and interacts with. This is one of the domains in your application. Another domain is the server. Usually communication happens between the server and client through an API. There's lots of different API technologies. Some of the popular ones are REST, GraphQL. A recently trendy one is gRPC. And there's quite a few more. And the next domain we're going to talk about is the database domain, which is used to process data. And there's another boundary here between the server and the database for reading and writing data. Once again, you have many options for communication across this boundary. Native drivers are usually quite low level and deal directly with the database's native query language, which is usually SQL. Query builders give you some low-level primitives to build complex database queries with. Finally, full-blown ORMs like Prisma are more high-level and offer more advanced features like migration management, model entities, middleware, and a bunch of stuff. So these tools that bridge the communication across boundaries can have varying levels of type safety associated with them. For example, a GraphQL API will always be typed, but a REST API might not be. So there are definitely trade-offs involved in choosing the right technology for your application. And to be clear, there are more boundaries that are relevant in web development, but this is like a 20-minute talk, so we'll focus on these three for today. So, okay, now we have some understanding of the domains and boundaries. And let's switch gears a bit and move back to the end-to-end type safety. So next, let's talk about why to implement end-to-end type safety. There is always non-zero overhead and complexity involved in introducing new tooling. So there should be a reason why we'd go through the trouble, right? So the first benefit is that it allows you to catch inconsistencies between the different domains in your application. We saw an example of this just a few minutes ago with the optional input type. In a real application, being able to catch errors like this quickly instead of at runtime can be incredibly helpful and can save you a lot of time. So here is an example of the same code, but instead of manually creating the types, I'm using a library. It's called GraphQL CodeGen to automatically generate the types for my GraphQL resolver based on the GraphQL schema. And you can see now that the compiler automatically picks up the mismatch between the ID field and complains about it. So the second benefit is that you can refactor with confidence. And so this is a screenshot from a few years ago, and I guess some of you can relate. So this is not a GraphQL specific problem. Refactoring is hard, and it can be tedious and error prone. One small change here can cause issues there, and 37 other places that you didn't even know existed. So having end-to-end type safety really shines here because it can inform of breaking changes and type mismatches in every domain of your application. And to be clear, end-to-end type safety isn't going to magically make the changes in those 37 places for you, but it can help you quickly identify many of the problematic areas. And I think that's a big win. So type safety in general has a few nice benefits that are probably worth going over. That, of course, if you're doing end-to-end type safety, you will get anyways. So IDs like VS Code or WebStorm or whatever you're using can use the types to give you better hints and code completion. It can significantly improve the developer experience in this way. It also allows you to quickly catch type-related bugs, which is really useful and also kind of obvious, so I won't elaborate too much on this. Finally, types are a form of documentation and help communicate the intent of your code with descriptive type names and function signatures. So coherent type definitions throughout your applications make your code much easier to understand and maintain. So all of these nice things, when taken together, result in increased developer velocity. You will have less bugs, be more productive, iterate faster, and be able to ship features with added confidence. So hopefully by now I've sold you on this end-to-end type safety thing. So now you naturally ask the question, how to actually implement this in your app. So unfortunately, the answer, like a lot of things in tech, is that it depends. There's no one right way to implement end-to-end type safety. There's a lot of different tools across different frameworks and languages. The right set of tools for you depends on your circumstances and context. My goal in this talk is not to give you an exhaustive list of the techniques out there, but I do want to show you one really good set of tools that you might consider, especially if you're using GraphQL and TypeScript. So we're going to move to a demo, but before that, I'll quickly introduce you to the app. It's this blog, and I'll be showing you the technology stack. So it has a Postgres database, a Node.js server, and it's running React on the front end. And needless to say, this app is end-to-end type safe. We're using two tools to achieve this. For the API, we're using GraphQL. We're also using a tool called GraphQL Code Generator to automatically generate types in our front end and back end based on the GraphQL schema. The database and server communication occurs through Prisma, which is a type-safe ORM for Node.js. Prisma also has its own schema language, which is used to define the shape of the database tables, and the language is very similar to GraphQL. So I'll quickly explain how GraphQL Code Generator works, the type generation library we were talking about. First, it will look at your GraphQL schema. Then, based on that schema, it will automatically generate types for both your front end and back end. GraphQL Code Generator has plugins for multiple backend languages, as well as different front-end frameworks. So it's quite flexible. Prisma works in a similar way. It first reads your Prisma schema. Then based on that schema, it updates the database and generates database types on the backend. So this is the overall architecture of the application. Let's take a quick look at it now. Yeah, so this is the blog. It really has only 2 pages, index page and a detailed article page. And well, there's not much to really see here. We'll move on to the code. This is the GraphQL schema. The queries and article type is mostly what we'll be dealing with. So in the backend, we have the GraphQL schema as well as the Prisma schema, which is for defining the database types. We're using Apollo server. And we also have GraphQL Code Generator, which is generating all these nice types for us. I will just make this a bit bigger. All these types for us automatically based on our GraphQL schema. In the front end, we're using Apollo client, and we also have this GraphQL types file here as well, which is typing all of our queries for us. So we are going to show you what a refactor or breaking change might look like when you're using end-to-end type safety. You can see we have these tags, personal and technology, in our blog. And the way this is implemented is super naive right now. We have an isPersonalArticle Boolean. And what our front-end application does is if it checks if it's a personal article and then just chooses personal or technology. So let's say we want another category, which is like other. So obviously this is not going to work. So ideally, we'd want to do something like this, right? But here you can see the TypeScript compiler compiling because category does not exist on the article type. So let's fix this. We are first going to start from the database and slowly move towards the front end. Let's get rid of isPersonalArticle. We add a category, and this is an enum. It will have 3 values. Okay. And in our backend, we will run a migration. This migration will, Okay, sorry. Dev. Yeah, so this migration will basically Okay, yeah, let me just explain what it does after I run it. Okay, Prisma migrate dev. Let's just run it like this. Yeah, okay, so what this migration will do is make these changes to the database. Call it whatever, and okay, we ran into an error. So let's just see what happened. The following migrations have been successfully run, but an error occurred while running the seed command. So let's go to our seed file, which is used to generate some dummy data. And here you can see that TypeScript is again complaining because isParsonalArticle no longer exists on the article type. So we can get rid of this, and we have another error. So the reason is this: we need to add the category field, which did not previously exist. So what we'll do is let's do something like this. We fetch all the categories from Prisma client. And again, even though it was on the database, it was automatically generated for us on the back end by Prisma. And let's add a category that is randomly generated here. Oops. Yeah, okay, so that looks good. Now no more complaints. Let's run the seed command again. All right, that went successfully. Now let's update our GraphQL schema. We get rid of isPersonalArticle again. We add a category field, which is a category, and syntax is pretty similar to the Prisma schema. We can just copy paste that here. So now we've updated our GraphQL schema. We need to run GraphQL code generator again based on this updated GraphQL schema. And I will quickly restart the backend server. Okay, so now we can move on to the front end. In the front end, we can try running, okay. That seems to be some kind of, yeah, okay, I'll just restart. Yeah, okay, so let me try running CodeGen in the front end, and it's complaining because our queries still have this personal article type, which should no longer exist. So let's get rid of that and add category. And we can run CodeGen again. Now, if we go to the place where we updated our category, this no longer has an error associated with it because this is actually a field in our GraphQL schema now. And if we move back to our app and quickly restart, we see we should have 3 different tags now: personal, other, and technology. So we can move back to our presentation. So hopefully that demo gives you an idea of why type safety is useful when working with an existing application. We wanted to make a breaking change and for a new feature. And at every step of the way, whenever we broke something or changed the shape of the database models or the API structure, TypeScript pretty much walked us through on how to fix this problem at every layer of the application. And again, we'll just summarize some of the things we talked about. So we talked about the what, why, and how of end-to-end type safety. We talked about the different domains and boundaries in our application. In particular, 3 domains that are most common in web applications. And we showed an example of an end-to-end type safe web app and demoed some of the benefits of end-to-end type safety. So that's all from me. You can get the slides and some resources scanning this QR code. So yeah.
Perfect.
Hope
All
you
right.
enjoyed the presentation.
Yeah. I am not always great when it comes to types, and so like getting any tips and tricks is always beneficial to me. So let's get some applause in chat for that, as well as any questions that you might have around end-to-end type safety. One thing I'm kind of thinking about is getting everybody on the same page around this, around having, backend I think is easier because again we have these things built into the way things are resolved, but convincing front end teams of TypeScript usage, or worrying about this in general. Oh, it just works. And I think there's an age old question about like, how do we get front enders onto TypeScript? I ask as somebody who doesn't use TypeScript enough. So I'm just kind of curious, how can we get more of that going on?
So this is definitely a cultural thing, and cultures across teams and technologies definitely, like companies, differs widely. So in my experience, the benefits do speak for themselves, and showing some of these benefits, like what adding TypeScript, what value it adds to your day to day, like it makes your life easier. It makes you like be able to read code faster. It makes you able to make changes faster. That's, I think, is one of the big ways to kind of motivate people. And one thing that's really nice about TypeScript is it's not all or nothing. You can definitely adopt it incrementally. And I know that goes against what I've been saying about like end-to-end TypeScript,
End to
all the
end.
things. Yeah, of course, but that's the goal, right? But type safety is definitely a spectrum. You don't have to like adopt all of these tools at once. You can definitely do it progressively, and I think that's a big help.
I actually like that you're kind of back to back with Matt Clark's presentation about like testing, and he had this huge flow chart about like all the testing and like going from a integration test to like the full ecosystem. And it's kind of the same way, like, let's make sure that we're doing this, and then we do everything, convert everything over.
Yeah, and also a lot of these tools are super easy to integrate. Like the tool I just showed, GraphQL Code Generator. It will probably take half an hour to an hour. It would actually probably take like 10 minutes to 15 minutes to just add it. It will probably obviously take longer to integrate all those types and make sure you're resolving all those type related issues, but adopting them can often be like very minimal overhead to zero overhead. So that's also, I think, really nice.
Yeah, making that adoption rate as low as possible, like or not adoption rate, the adoption hurdle, the pain of
Yes,
adoption,
the
as low as
difficulty.
possible. Yeah. All right. Well, we don't have, looks like, any additional questions. We did have a question midway through the presentation, but your presentation answered it. So
Okay.
well crafted tale to pose questions and then answer them. Oh, we do have a question now. Ty Cooper asking, what's the tool that you used in VS Code to check for type safety issues for the front end?
What tool did I use okay, so I didn't use any tool. It was just TypeScript, and that's literally the magic of TypeScript. It's going to tell you whenever there is any kind of type-related issue anywhere in your code. The tool that I used to generate the types was GraphQL Code Generator, and that generated the types. But once those types were there and you're using them in your code, it's just all VS Code and the TypeScript compiler. There's really no other extra tool that you need to add.
Yeah, that's during the build step or the processing step, is it errors out at that point. Cool. I think that
Sorry.
go ahead.
Yeah, could you repeat that?
Oh, I was just agreeing with you. And Ty's comment now is,
Okay.
I need to learn TypeScript.
Oh yeah,
Ex
absolutely.
exactly. All right. Well, I think that is it. So I appreciate you taking the time. I learned stuff because I'm always a newbie when it comes to types. So thank you so much, and I hope you have a great day.
You too. Good luck to the rest of the speakers. Bye.